Hello YouTube, welcome back to this series on creating a new programming language. So, last time we were trying to write this evaluate function and we didn't fully finish. We had evaluations for unary literal grouping, but we didn't have for, we also didn't have fully for the unary. Well, maybe we did. Let me see. Let's finish this. Let's do it this way. Token type, and then we will return an error with the message that token type is not a valid unary operator. That should do that. And then let's see here. We have two numbers, plus, minus, multiply, divide, greater than, equal, less equal, not equal, and equal. We have the same for strings. So now we also, let me do it like this. So we want to implement it basically for every possible combination of these, which is a little bit annoying. Okay, we can do, let's say we get a true with a equal, bang equal. You know what, perhaps we can do this. And then we'll say, okay, it's an okay, and it's a literal value from a Boolean, and it will be this. Now, probably it will complain that we haven't implemented okay, so first it complains about this, which is a valid complaint. And then it should complain down here. Yes, exactly. So we haven't implemented this not equals for the literal value. So binary operation not equal cannot be applied to this type. And I wonder how we would implement that. Maybe we just, can we just ask it to be partial eq? Yeah, that does it, because now we should be able to say this first of all, and this, and then we should be able to, I'm just going to comment it out in case I have to write it back, then we should not need those anymore. We try to run it. It doesn't work. And why? Because this one also needs to be commented out. Let's try again. Okay, now I should be able to say this, that one. Okay. So that means we just reduced the cases a little bit, which is nice. And actually, now we even support something like true equals true, in case you wanted that. We also get this kind of behavior. nil not equals true, which I guess is fine. And now let's stop here. Let's say that now anything else will return an error, and the error will say that the token type is not implemented for operands, and then we will simply give the two operands like this. So token type operands like that, and let's try to run that, because now if we try to say true times 2, then it will say star is not implemented for true and number. That will be fine for now. Okay, let's continue a little bit. So now he wants to talk about errors. We have already handled that quite a lot. Just by the way the match statement is set up. I mean, if we have like unexpected operands, it will just end up down here or something, or it will end up in one of these error cases that we handle specifically, explicitly. Whereas, of course, the way that he set up in the book, this cast will probably just fail completely if you have a string here or something. So let's see how he does it. So yeah, he's just casting, and those casts can fail. Even though the user code is erroneous, we want to make a usable language. We're responsible for handling that error. Sure. So actually, this is kind of an interesting example. Let's see if we can do it. So first, let's see if we can do like a proper one like this. Sure, that's true enough. Let's try this one. Good. Now what happens if we actually do this thing? Then it will just report minus is not implemented for muffin. That's kind of funny, but let's leave it. Okay, this one is a little bit better. So I think that points us to something we should do already. Yeah. Minus is not implemented for muffin. So right. So maybe I want to have a toType function. Where are we now? We're in the expression, and I want to go up here. We don't need these values anymore. And then we can simply say number. And let's just return string reference. String. And this one can be Boolean. And this will just be nil. So now if we run this and we try to say minus muffin, minus is not implemented for string. That's a little bit better than just returning the string. And anyway, you can't get a muffin, so we need to report a runtime error that at the end expression minus. That means we can't evaluate the division expression since there's no meaningful right operand. Likewise for this star. So when a runtime error occurs deep, it's an expression we need to escape all the way out. We are already doing that because we are using all these kind of smart unwrapping operators. We could print a runtime error and then pause the process and exit application entirely. And again, like we do it in quite a nice way. Just say what the error is, and then you can fix it and keep going. It doesn't exit or anything. Because we do this, everything is a result, and we just propagate it out. Yeah, so he has these new functions. So we have a lot of match cases. Arguably not that many more than he has, but like a few more because we have to, like for example, these he doesn't have, I guess. But those will now be separated out into functions like this, which also makes it a little bit harder to get nice error messages, I think. What I mean is that this error message is kind of like generic. I mean, you could give it in as a string, I suppose. But we can, in all of these specific cases, we can give like a tailor-made error message. Anyway. So throw some error. And it keeps the token. So this is how yeah, that's kind of nice. Let's look up here. So we don't have a token for these two, but here we do have tokens that kind of keep information about where the file it comes from. Now probably we will never have an error in this value at this stage, like in here in this file. Will be caught earlier. So probably it's fair enough not to care about this. But it's kind of interesting because now it means that maybe we should have a more complex error type that can keep extra information. Like, we'll keep that in mind because it's not so relevant now when we just have the rebel and like one-line statements, but later on when we try to interpret a full file, it's probably quite nice for it to like report to us that on this line there was an error and so on. And we will need the tokens for that, because if we go in here and look at the token, at least it has a line number, if not a actual like location. So that's another thing we could add to this. Actually, we could add like column number, so we both have line and column. Yeah. but whatever. So he has all these checks. We already handled that. Actually, now that we have this this thing, perhaps we can do the same for greater equal, things like that. Because I think it should be defined for strings as well. Let me just check. Let's just do greater. And it will be like lexicographical ordering. So it ran is A greater than B? No. No. Ah, yes, sure. How about AB? How about AB greater than AA? Should be true, yes. So, because these operators are overloaded in Rust, we can actually grab all of this, and I'm going to put it down here like so, and we can simply say that we don't want this anymore. It should just be X. And we also don't want number Y. It should be replaced with nothing. Sorry, it should be replaced with Y. And now we comment out those just to check. Because it cannot. Right. If it's true or false or something, we don't have an ordering, so I cannot just do it on everything. What's wrong here? Nothing. So actually, we need to replace X with string. Value is 1. And we need to replace Y with string value is 2. Oops. Yes, no, no, yes, no, oh. No, yes. No, no, yes. Great. Okay. Now we can compare strings. Great. And numbers. Okay. So he's just going on and on, adding these checks. Here's a good point. I guess that we evaluate the operands before we type check. So if there are any side effects, those happen even though the expression is not complete, not correct, like the full expression is not correct, but whatever. Hooking up to the interpreter, the visit method is sort of the guts of the interpreter class. We need to wrap a skin around to interface with the rest of the program. The public API is simply one method. Interpret. Yeah, I mean, there's not much to say. We already added that just by evaluating here and then spitting out the result. So here he wants to convert the thing to a string, which we don't need. We already have that implemented in various places. So nil, for example, should work. True works. How about this? Doesn't work. Yeah, so basically we don't need this because all of our expression object is already has a toString method. Yeah, basically we call it here, right? So So we don't, I think we write, oh, okay. Interesting, so that's already handled by Rust toString of a number. So we don't care about that. If a runtime error is thrown while evaluating its expression, interpret catches it. Sure, I mean, we don't have this catch thing. Yeah. So I think we want to do it, but not now. We want to change all these result types to a custom error type. The error content here is a string, but we want something a little bit more custom than that. So it can also keep the token that caused the error, so we can make a nice error message. The user is running a doc script from a file and a runtime error cause we set an exit code. Okay, that's interesting. So we also want to know the type of error, but then that could be included in this, right? We could set the type of error, like is it a parse error, is it a tokenizer error, is it a syntax error? evaluation error or something, you know. And then we can give different exit codes. So we'll do that next video, I think. Yeah, we have already been running it. Okay, now here's an interesting point. Now we are just evaluating expressions, and there's no, and for like the REPL, we may make, you know, define variables and things like that on one line, and then on the next line we will do something with the variable. So there has to be some sort of state that keeps living, and for that reason we will probably need to wrap this thing. So I think we want to do that now. Let's make an interpreter. Let's make it a module here. And right now it will be a public structure. So global state, something like that. Right, so it will be empty for now. And I think actually, I think it will be completely empty, but it will have a new function. Why not? And it will have a interpret function. So it should take immutable reference to self, because we may change the global state, and it should take in an expression that it's passing, and it will return a result, I guess. And the result will be, for now it will be a literal value or a string, which is a placeholder for the error message, and it will just do this. So it looks a little bit silly, but I think later on when we get the global state assigning variables and things like that, then it will make more sense. This one will actually do something useful. And now I have to remember how we do this. So it's a static interpreter, which is of type interpreter, and it's equal to interpreter new. Let's use the crate. Interpreter, everything, and now the result will not be this, it will be interpreter.interpret. Let's see. It did not work because we need it here. And it needs something to actually interpret. And we cannot call a non-constant function. There's also something unreachable I just saw. Well, that's nice that it's unreachable. We can remove it. There's no more to-dos. this doesn't work. How about this? Can I borrow as mutable? How about now? Use of mutable static. Mutable statics can be mutated by multiple threads. Okay. Interesting. Very interesting. So run prompt. So maybe this run function should get the interpreter to use. We can make the interpreter like not have a mutable reference. Like by using a ref cell or something, but or you know, one of these with inner mutability. But I don't really want to do that. It feels like it's cheating a bit. Because we cannot make a interpreter in here, because then the global state will be completely wiped every time. So yeah, screw it. And it's good, we remove that one. And here we will make a mutable interpreter. Which we will put in here. It's relatively hard to find. And same here. Let me just copy this one. Okay, let's try again. That didn't work because it got moved. How about this? Okay. Yeah, works like a dream. It's even correct. Okay, now we have the interpreter and it's set up to be ready to handle global state. And you can even like set up some predefined state if you want. Right, so we can, because this holds all the state and it's used to, it's applied here to the run function, we could imagine adding some state beforehand. So you could have access to some predefined variables, something like that. I don't know, just spitballing. We now have an entire language pipeline scanning, parsing, and execution. Congratulations, you now have your very own arithmetic calculator. Amazing. It's alive, and then there's a skeleton. Okay, so in the next one we'll start adding state. And I don't know if I want to do this first or fix up our error messages first. Let's do this. This is a little bit more interesting. And once we get super tired of not knowing where the error happens in our scripts, we will we will fix the error messages. Okay, see you next time.